Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel where you can get lots of math help, ask homework help for your math, or anything math related. So this particular video is going to be about ACT math, and we're doing 2.7 fractions and ratios. I already did my first video. We went through basically the notes on 2.7 fractions and ratios, and also did problems 1 through 9. In this video, we're going to do problems, I believe it's 10 through 18, which is like the second set. So let's go ahead and do those. And again, the book I'm using is called Unlimited Guide to the Math ACT. You can get this on Kindle, and it's a PDF version that I'm using. It's a pretty good book to help you prepare to take the Math ACT. All right, so again, we're doing 2.7, the second set of questions, which is 10 through 18. Okay. So let's go ahead and start with number 10. This one, we're just going to simplify. And for this one, we're just basically multiplying our variables, right? It's kind of like multiplying fractions. But again, we want to sit there and remember our exponent laws. So let's go ahead and multiply all this out. So I multiply all of my numerators. So x plus z, or multiplied by z, excuse me, times y times z. I'm just multiplying out all of my numerators. Right now, all my bottom numbers, my denominators, multiplying those out, it's just y times y times y. Now I can combine these. Remember, when we're multiplying like bases, it's almost like we're adding their exponents. There's always an imaginary one here. So on the bottom for my denominator, I get y to the third power, because 1 plus 1 plus 1. Then up top, I combine my like terms. X times x is going to give me x squared. Because remember, when I multiply two like bases, I add their exponents. And then the z, there's two z's here. So that's z squared. And that y, I can't combine it with anything. It just stays as y. And remember, our other exponent, when I divide two like bases, then I sit there and subtract their exponents. So then I'll get x squared, z squared. And then y, that 1 minus 3 is going to give me -2. But I always, when I have a negative exponent, I drop it down, right? And if I had a negative exponent in the bottom, I would bring it up, right? So I have x squared, z squared. And I drop this exponent down, y squared. And there's nothing else I can really combine or do. Notice these all have squared, so I can sit there and bring this out like it has right here. Or actually, no. Y to the third. Am I missing a y? Nope, that's right. 1 minus 2. Oh, that's an x. That's why. My apologies. I knew it didn't look right. Something didn't. This is an x, not another y. So that's x. And so this would be x squared, y squared times x. There we go. That looks way better. Okay. My apologies about that. So now I can sit there and combine. So this x squared, so I'll have x. Remember, there's imaginary 1 right here. I subtract when I have two like bases. 2 minus 1. Always x funky when I try to write right there. 2 minus 1. That z squared just stays the same. And that y is actually 1 minus 2. Okay, now that I have that, I just have x to the first power. I don't always have to write that first power because 2 minus 1 is 1, z squared. And then y to the negative 1, but that negative I just dropped down. Okay, so our answer is going to be C. All right, so this is one was really heavy on your exponent rules. All right, so let's go to number 11. For this one, we're dividing fractions. Another way I can rewrite this is 3 over 1, and then have my fraction bar here, 5 over 2. So I make them both look like fractions. Remember, this is just a sign for division. So it's like I'm dividing again, right? So I can sit there and write now, this is equivalent to 3 over 1 times, remember we change our sign when we're dividing fractions, change it to multiplication, and we flip our second fraction. So 2 over 5. All right. So this is going to give me 6 over 5. So our answer would be A. All right, so now let's do 12. 12 again, it's almost like we're dividing, okay? So what I'm going to do is I'm going to sit there and flip and turn that into a multiplication. So I have x squared minus 9 over x plus 1. And then times x squared minus 1 over x plus 3. Okay. And when I multiply these through, I'm basically multiplying my numerators and my denominators across. But for this one, we are going to have some factoring that's involved. Okay. And again, we will go over factoring in our later chapters. And again, if you want to know factoring right off the bat or refresher, just put in the comment and let me know, and I can send you some videos that will help you out with factoring. All right, so we're just multiplying these. Now this is where we have factoring. This is called a difference of squares. Notice I have my x squared, and I could find the square root of 3, which is, or the square root of 9, which is 3. So the rule behind that is I could sit there and write 2 binomials, because this is called the difference of squares property, x plus 3 and x minus 3. And that's called difference of squares property. 3. All right. Same thing with this, x squared minus 1. This is a square, and then 1 is a perfect square. Square root of 1 is 1. So again, this is the difference of squares property. I can write this as x plus 1 and x minus 1. If you do not remember the difference of squares property, write down in the comment, and I will sit there and make a video that will break that property down so you can understand it. All right. All right, now that that's done, I could sit there and start canceling things out. Since this is all being multiplied, I have a x plus 3, x plus 3 can go. And then I have an x plus 1 can go, since these are all being multiplied. Then I'm just left with x minus 3 and x minus 1. Right. But notice I don't see anything like that. So that means I can sit there and use FOIL to FOIL these two out. So I have x, and I'm using FOIL, x minus 1, where I take my first term and multiply it by all of my second term. And then take my second term right here, minus 3, and multiply it by all of my second one right here, x minus 1. This is called FOIL. Right? Then I distribute this through, I get x squared minus x, distribute that negative 3 through, minus negative 3x plus 3. I combine my like terms. I get x squared minus 4x plus 3. And that's my answer, which is going to be C. Right? Let's continue. 13. This is very similar to subtracting fractions. So first thing we want to do is get the like denominator. We can get our like denominator by multiplying our denominator together and then doing cross multiplication. So let's go ahead and do that. So when I do that, I do x minus 1 times x plus 1. Okay. And now I do the cross method for my numerators. I do x times x minus 1. All right, and then cross multiply the other ones and subtract it. I have x times x plus 1. And right here, you want to be careful because we do have a subtraction. So you're going to have to distribute that subtraction sign all the way through for your second term, right? That's where a lot of people mess up. So you have to remember, and I always put parentheses right there to remember that. So let's leave the bottom denominator as it is because there's going to be a trick to this, but let's go ahead and distribute out the top. So the top, I'm going to get x squared. All I'm doing is distributing out this x to hit each and every term in here. And then plus x. And this is minus. I'm going to keep that parentheses there to remind me I have to distribute that through. I have x squared minus x. But when I sit there and distribute that parenthesis, this negative x through like this, then I'll get, let me just write our denominator down here so I can show step by step what we're doing. X plus 1. All right, so then I would get x squared plus x minus x squared. And remember, we have to distribute that negative through, so this becomes plus x. Now our bottom, remember, like I said, this is a difference of squares. My x minus 1 and my x plus 1, I can rewrite that as a difference of squares, x squared minus 1, I can write that as. And then with my top, I can sit there and eliminate some of these, right? X squared minus x squared, that eliminates. And this just becomes 2x. So our answer for this one is going to be A. Okay, cool. If you have any questions on this one, because we did do factoring and we did pull out that difference of squares, go ahead and put your question in the comments. All right. Now let's do 14. Here we are. So if 3x minus 15 equals 2y minus 10 and y cannot equal 0, then x over y is equal to, okay, so for this one, the first thing we're going to do is solve for x. We want to isolate our x. So to do that, we can add 15 to both sides. Right. So when I add 15 to both sides of my equation, then I get 3x equals 2y plus 5. Now remember, I want to isolate my x completely, so then I divide by 3. Then I have x is equal to 2y plus 5 over 3. But they want to know what's x over y. So all I have to do is what I found, this 2y plus 5 over 3. I just have to write all this. This is a fraction bar over y. All right, so I simplify that down more. Remember, I can write this as a fraction as well. And so these are two fractions being divided. So I change it, the sign to multiplication, and I flip the bottom or the second fraction. So I have 2y plus 5 over 3 times 1 over y. And that just multiplies to my 3, so I get 3y. So the answer for this one is actually going to be E. Oops, not E. It's actually going to be D. Mm-hmm. All right. Very nice. So that's the trick to that one. Let's do 15. 15 is kind of like the one above. So what is the value of x over y? So our trick, again, is we want to solve for our x and then just put it over y. All right. So let's go ahead and do that. For this one, I have 1/2 xy equals 6 over 5 y squared. All right, so I want to solve for my x. I could sit there and divide both sides by y. If I divide both sides by y, I get 12x equals 6 over 5. I divided that y, right? So since I divided that y, it would look like that. There's an imaginary 1 right there. So 2 minus 1, I just get y. Okay. Y. Now I can multiply both sides by the reciprocal to get rid of this 1/2. So that's just 2 or 2 over 1. Remember, my whole goal, what I'm trying to do right now is isolate my y, or my x, my apologies. So then I have x equals 2, 4, 6, 8, 10, 12. 12 y over 5, right? Now I can just put this all over y, right? So my fraction bar, put it over y. I can write y as a fraction as y over 1. Remember, when we divide fractions, we change the sign to multiplication. And then we flip our second fraction. 5. So times 1 over y. My y's are actually going to cancel out. I get 12 over 5. Okay. So my answer is going to be D. So the trick for this one is just you solve for x, and then you put it over y and solve there. Right? If you have any questions on that one, just leave it in the comment, and I can explain it a little bit more if need be. Now let's look at 16. What is the value of x? We're solving for x here. So the first thing we're going to do is we're going to distribute this 2 over 3 through these two terms, all right? So I have 5 over 6 x equals 2 over 3 x minus 10 over 3. That's just multiplying 2 over 3 times 5. And then plus 5. That 5 was not in my parentheses, so I'm not going to multiply it by that 2 over 3. Now, if I want to sit there and get rid of all these fractions, I can multiply both sides by 6. Okay? Multiply everything, both sides by 6, because I don't want to deal with my fractions, right? This will cross out and become 5x. 6 divided by 3 is 2. 2 times 2 is 4. Another way I could have done that is I would have done like 2, because like 6 over 1, just for more clarification in case you needed. 2 over 3. I would multiply those through. 2, 4, 2, 4, 6, 8, 10, 12. I get 12 over 3. 12 over 3 just equals 4. So then I get 4x. Okay. Just to clarify how I got that. Same thing here. 3 goes into 6 twice. I have to multiply that 2 by this negative 10. So I get negative 20. 5 times 6. 5, 10, 15, 20, 25, 30. Right? Now I combine my like terms together. I get 5x equals 4x plus 10. Get all my x's together. Subtract that 4x from both sides. I get x equals 10, which is our final answer. So our answer is going to be B. Right? The trick with that one was just getting rid of our fractions, so we didn't have to deal with fractions. So we have 2 more. Let's do 17. If x over 6 plus x plus 1 over 7 equals 5x over 12, then what is the value of x? Again, we're solving for x. So we kind of want to find a way to get rid of all of our fractions. We could find the least common denominator of all these, but let's try to find an easier way. First, let's sit there and combine these two fractions, right? If I sit there and multiply my denominators together and then use the cross method that we do for adding fractions, then I can sit there and simplify it down a little bit more. So 6 times 7, that's going to be 42. Then I can cross multiply, right? So 6 times x plus 1 in my denominator. All right. And we're going to be adding these. And then I cross multiply again. I get 7x. And this is equal to, that's just what's on the other side, 5x minus 12. We're not touching that yet. So now let's simplify our left-hand side down a little bit more by combining like terms. So I have 7x. I distribute that 6 through up top right here to hit each and every term. So that's plus 6x plus 1 over 42. But I could sit there and simplify that down that more. 5x over 12. Let me just make sure I'm showing every step. Just to save room, I notice I can combine my 7x and my 6x. So 7 plus 6, that's going to give me 13x plus 1. Okay. Now after this, I notice that I have two rationals set equal to each other. So I can use the cross method again, okay? Which means I have 12 times 13x plus 1 equals, again, use the cross method, 42 times 5x. Okay. Now, again, I start simplifying this down. I distribute through this 12 to hit each and every term. All right. So 12 times 13, that's 156x. I'm just moving this up here. 156x plus 12. And that's going to equal 42 times 5. That's 210x. Okay. Now I combine my like terms. I'm going to move that 156 over to the other side. So then I have 12 equals 54x. Wait. Oh, my apologies. This was supposed to be a 6. Change this back to a 6. I knew something looked wrong. And then 12 times 6 is 72. My apologies. Make that correction on your paper. So this is 72. When I distributed, I just forgot to distribute it to that one as well, the 6. Okay. That's all right. And so then I divide both sides by 54. Divide both sides by 54. Right. So you're going to get x equals 72 over 54. But if you reduce this fraction, you can divide the top and the bottom by 18. And then you're going to get 4 over 3, which is C. Okay. And that's just reducing this fraction. All right. And so let's do the last one so I don't run out of time. All right. This is another ratio one, which is good. So the football team has a pretty good season this year with 2 over 3 of the games won. So 1 over 9 of the games tied. What is their fraction of loses? So I have 3 categories. I have winning, I have tied, and I have losses, right? So they gave me winning. Winning they gave me as 2 over 3. Tied they gave me as 1 over 9. But the thing is, I want my denominators to be the same, right? So if I multiply this 3 times 3, then I can get 9. But guess what? Since I do it to the bottom, I have to do it to the top as well. So after I sit there and multiply those by 3, 2 times 3 gives me 6. 3 times 3 gives me 9. I did that because I want to have the same denominator as my other ratio or my other fraction, right? So we know this one is going to have to be over 9. And the total is going to be 9 over 9. That gives me 1 in all. So I can do 6, 7. So 9 minus 7, it's going to give me 3. 6, 7. Yeah. So wait, 7, 8, 9 is going to be 2 because we want it all to equal to 9 over 9 if I add all these together. All right. So 6, 7, 8, 9. That's why that's going to be 2. Yeah. So 7 minus 9 is 2. Yep. So our answer would be B. All right. Cool. So that finishes off the second set. If you have any questions on numbers 10 through 18, put your questions in the comments under this specific video so I can answer them. If you have any other ACT questions that are really challenging in different books or online or you've seen on other practice tests, go ahead and drop them in the comments and I'll sit there and show you word for word how to get to the right answer on those. Okay? Thank you and thanks for watching.